In this video, we will consider matrix polynomial, and how to determine its value. By definition, polynomials are expressions, involving terms, which may have exponents, that are multiplied, added, or subtracted from each other. The degree of a polynomial is the largest exponent in the polynomial. Notice that the exponents are always non-negative integers in this case. Now, suppose this polynomial is evaluated at some matrix, which is denoted by capital X. The expression we get is defined as a matrix polynomial. Notably, matrix must be plugged in each term of the expression. Here, we should remember that matrix polynomials are defined for square matrices only. This is because we have matrix powers after we plug a matrix instead of scalar variable x. Furthermore, a free constant, A0, must be multiplied by the identity matrix, which is of the same size as matrix X. Let's take the example. Suppose a matrix A of size 2 by 2 is given. Also, the third degree polynomial is provided, which is asked to be evaluated at matrix A. At first, let's rewrite the given polynomial, by plugging matrix A into the given expression. One can see that matrix A is raised to the power of 3, and of 2. And, these powers of matrix must be determined. Also, the identity matrix of size 2 by 2 is introduced in the last term of the given expression. Let's start with A squared. This means multiply A times A, using usual matrix multiplication. In other words, we multiply A by itself. The product results in 11, -4, -8, and 3. Now, let's figure out a cubed matrix, which is a squared matrix times matrix A. That is, we plug the result we got in a previous step, and then multiply by A. This results in a matrix, with entries 41, -15, -30, and 11. Now, we are able to determine the value of matrix polynomial, by plugging the results we got. By performing the given operations with matrices, we eventually arrive at a final result, which is a matrix having elements, 22, -9, -18, and 4. Let's consider another example. The problem is, to determine, whether a given matrix A is a root of the given polynomial. Recall that, some number x is a root of a polynomial, if and only if, the polynomial equation is equal 0. For a matrix polynomial, this applies directly. But we require the polynomial equation to be equal to the null matrix. It works similarly as in previous example. First, we write the matrix polynomial, by plugging the given matrix A. Since the degree of the polynomial is 2, it is enough to determine the A squared. Using usual matrix multiplication, we get the matrix with entries, -2, 2, -6, and -2. By performing arithmetical operations on matrices, we arrive at the result, which is a null matrix. Therefore, we conclude that the given matrix A is a root of the polynomial, provided in the task. And that's it this time. Thank you for your attention.